Now, the first thing we need to decide on what are the design goals that will guide our system decomposition or system design or the general development of the system. Okay, so it is important for us to know what are the design goals, how are we going to prioritize them. Now, again, like the design goals define the qualities that we need to be addressed in the system. Okay, many of the design goals can be inferred from the requirements directly. You can find them listed directly in the requirements. Okay, most likely the non-functional requirements, but oftentimes you can always direct them from the application domain in general. So some of design goals are design goals that are applicable in this type of systems. Okay, so the requirements is one thing, one source of design goals. The general application domain or the how the applications of that type are supposed to work is also one source of design goals that you can drive from. Okay, and others you can just ask the client directly when they come up. Okay, so there are group of design goals that are available for us to pick from. Okay, just like when we mentioned in the non-functional requirements, you know, the list of the scalability, all this list of non-functional requirements. We don't have to use them all, but these are just some of the things that you may want to consider when you are considering your design goals. So there are 5 categories of design goals. There are performance, dependability, end user criteria, cost, and maintenance. Those 3 are related to the system itself, so they can be inferred from the requirements of the application domain. Now here, these 2 are related to how the system is going to be managed. Okay, so that's something that you can negotiate with your customer. Now for the performance criteria, the performance criteria generally are related to speed or space. Okay, so response time is the time between a user initiates an action and then the system responds to the user. And there's oftentimes modern systems have a very high requirement or high expectations of the response time. You know, sometimes the things takes takes more than a few not a few seconds. A few seconds is too much. If a response time takes more than a fraction of a second, people will start feel bored and like it doesn't give good experience to the user. There is a very high demand on the response time these days in modern applications. But other related performance criteria like throughput is just a number of tasks that can be accomplished in a given fixed span of time. Okay, and then there is the memory. Now, obviously, there is a trade-off here. Now, if you want a high response time, oftentimes the high response time requires using of the cache. So cache is like things stored in the memory that are ready to access. Okay, so that increases the response time. Obviously, the throughput also would require existence of memory. So oftentimes there is a trade-off between the memory and the throughput or the response time, but these are the general criteria for the performance. All right, there is a dependability group of criteria. Now, from the name, it's just design goals or qualities that are related to how much you can depend on the system. So robustness is related to how your system is going to respond to an invalid input. Okay, so in that, how can you depend on the system to prevent the user or to stop the user from entering an invalid input? Okay, reliability is just the difference between the expected behavior and the actual behavior. Okay, so how much you rely on the system to give you what it promises to. Now, the availability is how much the system is available. Sometimes now the opposite of availability is downtime. Okay. Now, depend from system to system, like this is a very critical criteria. In some systems, it's not as critical in others. So if you're creating a system in a hospital, for example, the availability is very critical there. But if you're creating a system for, like, a grocery store, now availability is important, but if the system is down, it's not a disaster. Okay. Now, fault tolerance is when something wrong happened, there is a fault happen. Can we rely or depend on the system to isolate this problem and continue working anyways or not? So that's fault tolerance. And then there is the security and the safety. The security is, as a terminology, is uh, is how we can depend on system to protect from malicious attacks. The safety, how can we depend on the system to not put people in danger? So if we're talking about, say, self-driving cars, so the security part is that how can you depend on the system, or how can you have your system defend against hacking into that car, for example. Okay, so that would be security. Now the safety, now how can you make the system, the design goal is to make that system make sure that to not put the people inside the car in harm's way. All right, now the cost criteria, obviously, how much money you are willing to put in each of these categories will determine how are you going to develop the system. Okay, so for example, the deployment is a very obvious example here. How much money you are willing to put in there. So can you afford to have your private cloud? Like cloud deployment is a very popular type of deployment these days. So can you afford to have your own private cloud? If not, then which of the public clouds, the services available, which one is more suitable to your budget? So how much money you are willing to put in the development, deployment, upgrade, the maintenance, and the administration would determine how are you going to implement it. Okay, so that's something that you need to figure out early on, even if it's not a requirement, I mean, a functional or non-functional requirement on the system itself, but it's something is going to determine, or it's going to affect how you're going to develop your system. And then there is a maintenance. Oftentimes, when you create a system, it's not like, okay, I created it, you deploy it, and that's it. Oftentimes, you may have responsibility to maintain it on a long term. So you may want to put these maintainability or maintenance design goals on your own. Most likely, your customer may not be. Well, it depends how technical technical background they have. It's someone that have significant technical background would need to decide on these. Usually, it's the development team. So extensibility is the ability of the system to add, or how easy it is that you would be able to add functionalities in the future. Modifiability, now how easy it is to change what was already implemented. Now, adaptability, how easy it is to adapt your system into different environment. Okay. Portability, how easy it is to port the system into different platforms. Okay, so you see difference between adaptability and portability. Here, the keyword, different application domains. Okay, so here it is adaptable to different so let's say, for example, a grocery store and a restaurant. Okay, here this is the goal, is to create a system, a payment system that works in a grocery store and the restaurant. So these are different application domains. Not so different, but a little bit different. Now, how adaptable your system is gonna be. Now, portability is how is it gonna be, how would it be able to run on different platforms? Readability, how is it easy to understand your code? And traceability of the requirements, that's how easy it is to trace the requirements to their implementation. Or not only the implementation, throughout all the artifacts between the requirement and the implementation as well. All right, now the last criteria is the end user criteria. Now there are two main criteria: the utility, which is how useful the system is to the user. Now the usability is how easy the system is to the user. Now, Google is very good at the usability. That's one of the major reasons of their success, is that all their services are very high in usability. It's almost, you can just take any service that is provided by Google and you will be able to use it without almost no training. So usability is a desirable design goal. Okay, it's different from utility. Utility is just how useful it is, but what benefit? I mean, if it's something that's very useful but it's very hard to use or very confusing to the user. So sometimes usability can have a little bit of priority, because even if it's high in utility, but it's not accessible to the user, so this utility is not going to be useful. All right. So these are the suggested design goals. It's not a standard. You're not limited to these lists. These are just suggestions of things you think about when you are designing on your design goals, deciding on your design goals. Now, another thing you need to keep in mind is that there's always a trade-off. So when you prioritize speed, then you have to provide space. If you don't have resources to provide space, then you're gonna have to compromise the speed. So which one is more important? Okay. Also, if you wanna be strict on delivery time, you may have to sacrifice implementation of some functionality. If you don't want to do that, then you have to be flexible in delivery time, or you will have to sacrifice quality, or you need to put some money in staffing. So there's always a trade-off. A decision needs to be made, and in order to prioritize which is more important for the system, and for the client, for the benefit of the client.